Chapter 3 of the Stormwater Management Guidebook covers the Stormwater BMP specifications. In this video, we'll talk about green roofs. The guidebook is arranged such that the specifications for each BMP type are laid out in the same format, and it includes the following subsections. Here's an example of a typical green roof, and we'll talk about the design and the components of this BMP in detail. So green roofs are an excellent practice, especially in high density development areas where there is not a lot of land available for other BMPs. So where there's only really a building with a roof, you often have to use that roof for the stormwater management. There are a variety of vendors and systems out there, and the Stormwater Management Guidebook does not specify which vendor is preferred, just the general design parameters and the specifications that must be met by that system. The general requirements are set based on ASTM specifications. There are two generally different types, the extensive or intensive green roof, which I'll show in a moment. The green roofs must be designed based on structural considerations. So DOEE does not review the structural design considerations, but it is reviewed by the structural reviewers, and so you must account for that in your design. They generally have a higher installation cost compared to other BMPs, but when you think about the other co-benefits of the green roof BMP, which can include increased roof longevity, the additional urban environmental benefits of the habitat that's being created in an urban environment, this can be a very important component of the stormwater management on a site, especially when those higher costs are balanced out by the benefits. So you can see here some examples showing another benefit, which is really the aesthetic benefit. So the top showing the intensive green roof example is where you have larger trees and shrubs, sort of a higher profile. And on the bottom, an extensive, where there are a lot of sedums, a lot of sort of low growing ground cover plants. In both examples, you can see that it's a bit of a park-like atmosphere up on what otherwise would just be a rooftop, right? So this is one of the co-benefits that can make these green roofs advantageous in particular settings. So as I mentioned, the structural capacity of the roof is a consideration for the feasibility of the green roof. The roof pitch is also a consideration. Green roofs can be built on pitched roofs, but some adjustments need to be made to ensure that the media and the planes are not going to move. There are setbacks required from HVAC and other protrusions in the roof and from the building edge, and it must comply with all building codes and fire code. In terms of the stormwater management feasibility, we have a maximum contributing drainage area to the green roof. It can be no more than 100% of the green roof area itself. So if you have a 500 square foot green roof, for example, you can contribute runoff from an additional 500 square feet of, say, higher level roof or adjacent rooftop if you can get the flow to contribute to the top of the roof. But we don't allow more than that 100% of the green roof area to contribute on to the green roof. You also need to have some flow dissipation to spread the flow. So if you're conducting runoff from a higher level roof through a downspout, if it's discharging at a point, you want to dissipate that energy to make sure that it's not going to wash out the plants or the media that's in that area of discharge. Conveyance and pretreatment. So it's important that the drainage layer and the roof drains can safely convey the overflow. So you'll have to show a detail of the roof drain and how it's going to interact with the green roof. There aren't any requirements for pretreatment because it's receiving runoff from rooftops, which are generally relatively clean compared to other surfaces that stormwater BMPs treat. The general layout of a green roof, it can vary, but it's generally follows this specification for each layer here, where you have to have the structural support, the roofing membrane, the waterproofing or the root barrier, insulation, and the water storage, growing media, and vegetation. Those top three, the vegetation, the growing media, and the drainage or water storage layer, are the three that we consider in the stormwater retention. Sometimes, increasingly, solar panels are put on top of roofs, and you can incorporate a solar panel or a solar array with a green roof and get a lot of kind of double benefit for that same space on the rooftop. The important part here is that it just must meet these minimum requirements in terms of separation and elevation of the structure, the solar panel off of the roof, which are really designed to allow for maintenance access, right? So there's a 3-foot minimum space between solar panel rows so that someone can physically get in between the rows. And then there is a 2.5-foot minimum on the high end and a 1-foot minimum on the low end. So there must be at least a 2.5-foot minimum space where someone can actually get under the solar panel and perform maintenance to the green roof that's underneath it. Also allows for lighting, but that it's mostly a maintenance issue of why these spacing requirements. This also applies to HVAC or other equipment that's an elevated structure. So you have to have that 3-foot minimum and then the 2.5-foot minimum to allow somebody to get under and perform that maintenance. Sizing for the green roof is based off of this equation. So the storage volume is what we're going to calculate to see how much retention we're going to get from a green roof. And so the storage volume in cubic feet is a function of the surface area of the green roof and the media depth in inches and the media maximum water retention capacity. So this is going to be a verified, tested data point that you're going to have to supply. In the absence of the verification data, you can use the 0.1 baseline default, which is much lower than what it would actually be if you get this system tested. Then you have the drainage layer depth and the verified drainage layer maximum water retention capacity, which again needs to be supported by verification data. So you can see this equation here. You're looking here at the the media layer depth and the media water retention capacity. So this is the storage capacity of the media layer, and here is the storage capacity of the drainage layer. You add those together, multiply by the surface area, and you get a volume that is your potential storage volume based on the sizing and the media and drainage layer characteristics of this green roof. Green roof landscaping criteria, there are no really strict requirements on this, but the idea is that the plants need to be able to withstand the very harsh conditions of an urban rooftop, which include drought, fire, wind, snow loading, heat stress, right? This is a very extreme environment. Hopefully not too much fire up there, but it's very hot. It's a lot of stress. And so generally we have a lot of these plants in green roof plantings that are adapted to these extreme environments. So a lot of sedums. You can put higher, sort of more sensitive plants in a green roof, but it generally requires deeper media depth, and the watering of these landscape elements is a consideration as well, which I'll get into in a moment. So for the extensive green roof and the intensive green roof, you have to have some sort of temporary irrigation, right? So during the establishment period, it's critical to make sure that these plants are irrigated and survive through that 6-month, first year and a half of establishment to make sure that the plants thrive and you don't get this barren wasteland where the sun just scorches and burns up all the organic matter that's in that media when there's no plant coverage on it. You need to have that irrigation for establishment, and then during drought times as well. So this is a temporary irrigation, a hose bib or some other temporary source of water. Permanent irrigation can be used on the intensive green roofs, but not on extensive green roofs. So the reason for that is the extensive green roofs are planted with sedums and other plants that shouldn't need permanent irrigation. If you want to plant those, larger, more ornamental plants, the deeper intensive green roof media can be used, but to account for the fact that there's permanent irrigation, that there's water that's going to be taking up some of that storage capacity of the media, you have to reduce the retention value that's calculated by half. So as I mentioned, the unirrigated retention value is just equal to the storage volume, whereas the irrigated retention value for an intensive green roof, if it's permanently irrigated, would be 50% of the storage volume.